the name of Almighty God, I am Maxwell and today I want to talk about chemical reaction during module in constant multiphysics simulation software. Now I want to go through the liquid phase Maxwell Stefan diffusivity. The Maxwell Stefan liquid diffusion coefficients are calculated from the liquid diffusion coefficients at infinite dilution. The diagonal values should be ignored and are set to zero. The Vinus reference 71 model for diffusion in binary solution can be extended to multi-component system based on the reference 72, where Dij x occur tends to 1 denotes the Maxwell Stefan liquid diffusion coefficient for species I and J in the limit of pure species K. If K is equal to J, it represents a binary system of species I and J, where I is infinitely diluted. In addition, at infinite dilution, the thermodynamics factor activity reference 57 becomes unity, and Maxwell-Stefan diffusivity equals to fixed diffusivity. Similarly, we have these formulation models for the Dij. X tends to 1 for K is not equal to I and K is not equal to J remain to be defined in such a way that symmetry is ensured. And to ensure continuity, if both species I and J vanish for binary system equation 6-250 reduces the Venus interpolation formula. Vesselin and Krishna, reference 72, propose this formulation leading to this formulation. Kojiman Taylor is found on a limited number of systems that this provides better results leading to this formulation, and it's asserted that this is a reasonable estimate. Krishna Van Button, on the basis of the data obtained from molecular dynamic simulations, proposed the following Venus-based reference 71 interpolation. The model reduces to the Kojiman-Taylor model for xi is equal to xj. The value of the Dij xk tends to 1 is undefined in the limit of both xi tends to 0 and xj tends to 0 from the physical point of view. This is inconsequential as the value cancels out in the expressions obtained for the fluxes using the Maxwell-Stefan equations. Nevertheless, in order to obtain well-defined values and composition derivatives of Dij tends to oneself, the equation is modified to as follows, where epsilon x is equal to 10 to the power of minus 10 is taken as a small composition. The limiting case for both xi tends to 0 and xj tends to 0 also reduces to the Kojiman-Taylor model. This equation leads to this equation. Surface tension. The available surface tension models are presented below. Gas liquid surface tension ideal. The gas liquid surface tension is predicted by ideally mixing the pure species correlations. It is independent of pressure, vapor temperature, or composition. Where the vapor liquid surface tension correlation sigma IVL must be specified for all species I and are evaluated at the temperature of the liquid phase, a winter field. Following winter field reference 76, the vapor liquid surface tension is predicted by mixing the pure species correlation according to this formulation. It is independent of pressure, vapor temperature, and composition. The vapor-liquid surface tension correlations and liquid density correlations must be specified for all species I and are evaluated at the temperature of liquid phase. I read a literature that was written by the Ackerberg, and the name is CFD analysis of the gas flow inside the vessel of a hot isostatic press. Also, Bishnoi, their name is accuracy and consistency comparisons of 10 cubic equations of a state of polar and nonpolar compounds. Another one was written by Pauling and name is the properties of gases and liquids. Another was written by Calapiran and the name is Memory sur la puissance motrice de la chaleur. The next one was written by Robinson, and the name is a new two constant equation of state. The next was written by Tua, and the name is a new generalized alpha function for a cubic equation of state. The next was written by Redlich. The name is on the thermodynamics of solutions and equation of state, fugacities of gaseous solution. The next was written by Soa. The name is equilibrium constants from modified Redlich-Cohen equation of state. The next one was written by Daubert, and the name was a modified solved equation of state for phase equilibrium calculation systems containing hydrogen. The next was written by Cooper, and the name is revised release on the IRPWS Industrial Formulation 1997 for the thermodynamic properties of water and steam, the International Association for the Properties of Water and Steam. The next was written by Watanabe, and the name is revised supplementary released on backward equations for the functions for region 3, and the next one was written by Marcy. The name is supplementary release on backward equations for specific volume as a function of pressure and temperature. The next one was written by Cedar, and the name is General Correlation of Vapor-Liquid Equilibria in Hydrocarbon Mixture. The next one was written by Heidelbrand, and the name is The Solubility of Non-Electrolytes. The next one was written by Street, and the name is Vapor-Liquid Equilibria for High Temperature, High Pressure Hydrogen Hydrocarbon Systems. The next one was written by Frankfurt, and the next one was written by Heidelbrand. The name is Regular and Related Solutions. The next was written by Wilson. Name is Vapor Liquid Equilibrium. A new expression for the excess free energy of mixing. The next was written by Renault, and the name is Local Composition in Thermodynamic Excess Function for Liquid Mixture. The next one was written by Abrams, and his name is Statistical Thermodynamics of Liquid Mixture, a new expression for excess Gibbs energy of partially or completely miscible system. The next was written by Bechoin-Slund, and the name is Group Contribution Estimation of Activity Coefficients in the Non-Ideal Liquid Mixture. The next was written by Kolbe, and the name is Vapor Liquid Equilibrium by Unifact Group Contribution Revision and Extension. The next was written by Ramusen, and the name is the Vapor Liquid Equilibrium by Unifact Group Contribution Revision and Extension. The next was written by Weidlich. The name is Vapor Liquid Equilibrium by Unifact Group Contribution. The next was written by Ramusen, and the name is Vapor Liquid Equilibrium by Unifact Group Contribution. The next one was written by Hansen. The name is Vapor Liquid Equilibrium by Unified Group Contribution, the revision and extension for 5th edition. The next was written by Wittig. The name is Vapor Liquid Equilibrium by Unified Group Contribution. The next was written by Balsbe. The name is Unified Parameters for 4 new groups. The next one was written by Hannickson and Thomson, and the name is a new correlation for saturated densities of liquid and their mixtures. The next one was written by Racket. The name is Equation of State for Saturated Liquids. The next one was written by Todos. The name is the thermoconductivity of nonpolar substances in the dense gases and liquid regions. The next one was written by Yoshimura and Masuduka, and the name is Thermoconductivity of binary gas mixture at high pressure: nitrogen, oxygen, nitrogen, argon, carbon dioxide, argon, and carbon dioxide, methane. The next one was written by Lindsay, Thermoconductivity of gas mixture. The next one was written by Vasiliou. The name is Heat Conduction in Gas Mixture. The name was written by Cooper. The name is released on the IRPS formulation 1985 for the thermoconductivity of ordinary water substance. The next one was written by Wilkie, a viscosity equation for the gas mixture. The next one was written by the Brokaw, and the name is approximate formulas for the viscosity and thermoconductivity of the gas mixture. The next one was written by Leonard Jones, and the name is on the determination of molecular fields from the variation of the viscosity of a gas with temperature. The next one was written by Stockmeyer. The name is second viral coefficients of the polar gases. The next one was written by Romans, and the name is critical evaluation of Leonard Jones and Stockmeyer potential parameters and some correlation methods. The next one was written by Davidson, and the name is simple and accurate method for calculating viscosity of gases mixture. The next one was written by Todos, and the name is The Viscosity of Pure Substances in the Dense Gases and Liquid Phase. The next one was written by Christensen, and the name is Phase Behavior of Petroleum Reservoir Fluids. The next one was written by Pedersen, and the name is Viscosity of the Crude Oil. The name one was written by Hanley, and the name is the viscosity and thermal conductivity coefficient for dense gases and liquid metal. The next one was written by Pedersen, and the name is an improved corresponding stage model for the prediction of oil and gas viscosities and thermal conductivities. The next one was written by McCarthy, and the name is modified Benedict Webb-Rubin equation of state for methane using recent experimental data. The next one was written by Murad and Gubbins, and the name is corresponding states correlation for thermodynamic conductivity of dense fluids. The next one was written by Cooper. The name is revised release on the IRPWS formulation 2008 for the viscosity of ordinary water substance. The next one was written by Dowke. The name is revised release and the pressure along the melting and sublimation curves of ordinary water substance. The next one was written by Gabito, and the name is experimental and theoretical determination of a heavy oil viscosity under reservoir conditions. The next one was written by Misonard, and the name is Conductive Thermico des Liquids Organiques Density or then Group the Liquids. The next one was written by White, and the name is Ternary Liquid Mixture Thermoconductivity. The next one was written by Rowley, and the name is a local composition model for multi-component liquid mixture thermoconductivities. The next one was written by Newen. The scientific papers of James Kellett Maxwell, it's for Cambridge University Press, 1890. The next one was written by J.C. Maxwell. The name is On Dynamic Theory of Gases. The next one was written by J. Stefan, and the name is Über das Gleichgewicht und die Bewegung, insbesondere die Diffusion for Gasmengen. And the name is Sitzungsberichte der Kaiserlichen Akademie der Wissenschaftlichen Wein. The next one was written by Taylor. The name is Multi-Component Mass Transfer. The next one was written by Fuller. The name is a new method for prediction of binary gas phase diffusion coefficients. The next one was written by Fuller, and the name is diffusion of halogenated hydrocarbons in helium, the effect of structure and collision cross-section. The next one was written by Wilkie Lee, estimation of diffusion coefficients for gases and vapors. The next one was written by Neufeld, and the name is empirical equations to calculate 16 of the transfer collision integrals O to the power of L s star. The next one was written by Wilkie Kang, and the name is correlation of diffusion coefficients in dilute solutions. The next one was written by Hadoop, and the name is prediction diffusion coefficient for non-electrolyte in dilute aqueous solutions. The next one was written by Koeman, and the name is modification of the Stokes-Einstein equation for diffusivities in the dilute binary mixture. The next one was written by Kalus, diffusion coefficients in dilute binary mixture. The next one was written by Minehas, and the name is Correlation for Prediction of Molecular Diffusivity in Liquid. The next one was written by Lucas, The Correlation for Prediction of Diffusion in Liquids. The next one was written by Rodin, Correlation for Prediction Diffusion Coefficient in Alkalis. The next one was written by Bondi. The name is van der Waals, volume, and Rodin. The next one was written by Hirschfelder, and the name is The Molecular Theory of Gases and Liquid. The next one was written by Williams, Diffusion Binary Solution. The next one was written by Vesseling, and the name is Mass Transfer. The next one was written by Taylor, Estimation of Diffusion Coefficient in Multi-Component Liquid System. The next one was written by Vesseling and Boland. The name is Multi-Component Diffusivities from the Free Volume Theory. The next one was written by Fan the dark correlation for multi-component diffusion in liquid mixtures of linear alkanes and investigation using molecular dynamics MD simulation. The next one was written by Winterfield, an approximate theory of interfacial tension of multi-component system application binary liquid vapor tension. The next one was written by Carlson, Don't Gamble with Physical Properties for Simulation. So thank you so much for watching my tutorial video until then. Today is 22nd of the May 2026, and time is 4:22 p.m. Also, I hope that you enjoyed this literature which was related to chemical reaction during finally I recommend you to read the 77th reference that it was written by Carlson, and Don't Gamble with Physical Properties for Simulation and Reality. So also you can download the appropriate and related quantum physics simulation from github.com/masterscript. And today is 22nd of May 2026. Time is 4:23 p.m.